In this video, I want to begin talking about random variables. Okay, so this is a bit of a review, but it'll lead us into a random variable discussion. The average amount of rainfall in May in Minnesota is 6.39 inches with a standard deviation of 2.33 inches. Assume this amount is normally distributed. So my reminder here, remember how to do Statistic on your calculator. I will quickly pull in an example when we get to it, but remember where that is. It's under distribution, which is second vars on the TI 83 and 84. All right, so let X be the amount of rainfall in inches in May of 2015. So what's the probability that X is greater than 10? Well, remember, our work consists of drawing the curve and saying we are in a normal distribution with a mean of 6.39 and a standard deviation of 2.33. So this shows the distribution we're talking about is normal, as well as the values that we need. And then the reason we've drawn the curve is to shade, for us, X is greater than 10. So I'm going to try and do this kind of a color coding here. So we put 10 in, and we're looking greater, so we shade. Okay, so I'm going to quickly show how to do this on the calculator. Okay, I've chosen to do this on a TI 83. The TI 84 is a little easier because it actually kind of gives you a fill-in-the-blank template to say. So if you remember, the order is the lower bound. So for us, we're shading from 10 up. And then a really large number, I chose to do 1E99, so 1 with 99 zeros after it. And then the mean, and then the deviation. And it's always lower bound, upper bound, mean, deviation. So 0.061, I guess we could say, that's our probability. Okay, so let me move this out of the way. Less than 5. Okay, so I'm going to change colors here. Less than 5 would be right about in here. Okay, so we shade less than 5. So now let me show the calculation for this. So here you can see again a lower bound. I did a large negative this time, so it's -1 with 99 zeros after. And then the upper bound was 5 and mean and standard deviation. So 0.275 is my answer. Okay, let me put this out of the way. And finally, between 6 and 9. Okay, so 6 is probably right in here. 9 is in here somewhere. That's 6 and 9. Okay, so now let's look at this calculation. All right, so you can see the lower bound was 6, the upper bound was 9, mean and standard deviation. So a solution of 0.43. Now, why I said this was, it is review, but why it's a lead-in to what's called a random variable is because of this, this piece right here. Let X be the amount of rainfall, and then we've defined it and then used it. Okay, this is a random variable. It's a variable that we use to kind of shorten probability problems to help us write things and kind of save our notation, okay, and keep consistent. This, we're about to talk about two kinds of random variables. A discrete random variable where there are a countable number of outcomes, and a continuous random variable where the number of outcomes are infinite. This is what would be called a continuous random variable, this situation, because there are an infinite number of rainfalls. Looking at kind of a broad level, there are an infinite number possible. Just because we've never had more than 15 inches of rain doesn't mean we may never have that. So, like I said, there are an infinite number of possibilities, and that's why this is called a continuous random variable. We'll come back to that. So you see this, what is a random variable? A variable whose value is based on random phenomenon. As I said, we use them for probability problems. That's really, and random phenomena, of course, lead us to a probability discussion. So example, you flip a coin 5 times and count the number of heads. Instead of having to say the probability of 4 heads out of 5 flips, we define X as the number of heads out of 5 flips. What's the probability that X is 4? It doesn't really seem like a shorthand unless you use this variable multiple times. Okay. Oftentimes we draw what's called a probability distribution, where we list all of the possibilities that our random variable may take, and then we list the probability of those outcomes occurring. Let's do an example of that. So, a discrete random variable is one with a countable number of outcomes. Remember our rain example in the beginning, that was a continuous. There are an infinite number of outcomes. A discrete means, no, we actually can count. So I have some examples here that you can read through. I've chosen a very simple example here that I flip a coin 3 times and count the number of heads. So let me begin by just writing over here the possibilities. So there are the 8 possibilities in my sample space. Okay, so what is the probability that I got 0 heads? Well, there is only one outcome, right? So it's 1 out of 8. The probability of getting heads one time is 3 out of the 8 outcomes. The probability of getting 2 heads, meaning 1 tail, is also 3 out of the 8 outcomes. And the probability of getting all heads is 1 in 8. Okay? This is our probability distribution. We have listed the possibilities, possible outcomes, and we've listed the probability of each. The probability that x was 2, well, we already calculated that. It's 3/8. The probability that x is greater than 1, meaning greater than 1 means these two, so that is 4/8, or 1/2. And the probability that we are less than 2, meaning down here, less than 2, is 4/8 again, or 1/2. So again, this is a discrete random variable because, if I said I'm flipping the coin 3 times, counting the number of heads, there were only these 4 possible outcomes. Okay? In the next video, we're going to talk about how to calculate the expected value.